The next topic, integral calculus. Integration is nothing but reverse process of differentiation. Integration is an area finding process. In geometric shape, we can directly find the area. For example, the area of the rectangle is length into breadth. In another example, the area of the circle is pi r square. Consider for a example the area of the rectangle is given. There are two axes, x-axis and y-axis. The f of x is equal to z. Therefore, the breadth taken as a x-axis. Therefore, area is equal to b minus a into c. For irregular shape, we cannot directly find the area. But for irregular shape, the process of integration is used. The given diagram is irregular shape of the curve, irregular shape curve. How will you find the area of the irregular shape? We divided the area into rectangular strip. For in this the graph, a to x1 taken as del x, x1 to x2 del x, x2 x3 del x, x3 to b del x, equal number of strip, rectangular strip. In y-axis, f of a, f of x1 plus f of x2, f of x3, f of b. The area under the curve is approximately equal to sum of area of each rectangular strip. Therefore, the area is given by a approximately f of a into del x plus f of x1 into del x plus f of x2 into del x plus f of x3 into del x. The another curve. How will you calculate the accurate value of irregular shape? As we increase the number of strips, the area evaluated become more accurate. If the area under the curve is divided into n strip. Therefore, upon எவ்வளோ நம்பர் ஆஃப் ஸ்டெப்பை நம்ம வந்து டிவைட் பண்ணிகிட்டே போகிறோமோ அந்த அளவுக்கு நமக்கு வந்து irregular ஷேப்புடைய ஏரியாவுடைய வேல்யூ வந்து நமக்கு அக்யூரேட்டாக நமக்கு வந்து கிடைக்கும். Therefore, the equation become the n number of strips are given. The divided into n number of strips, the area of the curve is given by a is equal to summation of n is equal to 1 n f of x of n into del x of n. As the number of strips goes to infinity, n is equal to infinity, the sum becomes an integral. Therefore, a is equal to a to b f of x dx. There are two limits, lower limit, upper limit. Therefore, a to b. The integral will give the total area of the under the curve taken as f of x. Therefore, the limit value area is equal to integral of a to b f of x into dx. The limit value del of x is equal to 0, I is equal to 1, the summation of n f of x of I into del x. Some example are given. First example, we find the value of work done. What is the formula for work done? Force into distance. Force taken as a f of x. The distance between, we are given a distance, the force or act, the work is done. Therefore, the work done is the area under the force displacement graph is shown in the figure. Therefore, work done is equal to integral of a to b f of x into dx. Therefore, the lower limit value is equal to a, upper limit value b. Therefore, this equation becomes w integral of a to b f of x dx. In the another example, impulse. What is meant by impulse? A great force acting in the very short interval of time. Therefore, impulse I is equal to f into dt. Therefore, the limit value 0 to t1. The t first lower limit t is equal to 0, upper limit t is equal to t1. The next one, average velocity. Consider a particle located initially at a point P. At a point P, the position vector r1 vector. In a time interval, the point del t, the particle is moved to the point Q. At a point Q, the position vector r2 vector. The displacement vector is del r vector is equal to r2 vector minus of r1 vector. Displacement means difference between the final and initial position. The average velocity is defined as the ratio of the displacement vector to the corresponding time interval. Therefore, this equation becomes b average vector is equal to del r vector by del t. It is a vector quantity. The direction of average velocity is in the direction of the displacement vector del r vector. The another topic, average speed. The average speed is defined as the ratio of total path length travelled by the particle in a time interval. Therefore, average speed is equal to total path length by total time. The next one, instantaneous velocity or velocity. The instantaneous velocity at any instant t or simply velocity is defined as the limiting value of the average velocity del t into 0 evaluated at time t. The another definition of velocity is equal to the rate of change of position vector with respect to time. Velocity is a vector quantity. V vector equal to limit of del t into 0 del r vector by del t equal to dr vector by dt. We know that r vector is equal to x of I cap plus y of j cap plus z of k cap. Therefore, r value substitute in this equation. Therefore, v vector is equal to d by dt. R value is equal to x of I cap plus y of j cap plus z of k cap. We arrange this equation. V vector is equal to dx by dt I cap plus dy by dt j cap dz by dt k cap. In this equation, dx by dt equal to distance by time taken is a velocity. Velocity is a x component. That is x component of velocity. Then dy by dt is equal to v of y. This is y component of velocity. dz by dt is equal to v of z. This is a z component of velocity. This is the speed. Next one, we find the value of speed value. V is equal to root of v of x square plus v of y square plus v of z square. Speed is a scalar quantity. The unit of speed is meter per second. The next one, momentum. The linear momentum or simply momentum of a particle is defined as the product of mass with velocity. It is denoted as p vector. Momentum is also a vector quantity. The momentum p vector is equal to m into v vector. It means mass into velocity. The direction of momentum is also in the direction of velocity. The magnitude of momentum is equal to product of the mass and the speed of the particle. Therefore, p is equal to m into v. V means speed. In component form of the momentum can be written as px of I cap, py of j cap, pz of k cap equal to mvx I cap, mv of y j cap, mv of z k cap. P of x is the x component of momentum. It is equal to mv of x. P of y is the y component of momentum. Is equal to mv of y. P of z is the z component of momentum and is equal to mv of z. The momentum of the particle plays a very important role in Newton's law. The momentum can be explained by simple example. A butterfly and a stone both moving towards you with the same velocity. If both hit your body, the effect will not be same. The effect not only depends upon the velocity but also on the mass. The stone has greater mass compared to butterfly. The momentum of the stone is greater than the momentum of butterfly. It is explained state the motion of the object. Momentum formula of P is equal to mass into velocity. Therefore, the unit of momentum is kilogram meter second minus 1.